Welcome students. In this video, we will be discussing time and space complexity analysis of circular linked list. Already we have the code of both the iterative as well as recursive procedure. So we will just find the time and space complexity analysis for both the approaches separately. Coming here to the first in iterative approach, let us take the function signature as t of n, time function, where n is the total number of node available in the linked list. First line it will be taking actually n unit time it will be taking, okay, for just assigning first to temp. Then coming here to do block will not be executed for only one time, it will be executed for more number of times because it is like a loop. So how many times this do will be executed? That's a question. It will be executed for, see, for first node it will be executed once. Second node, totally let us consider that we have 5 nodes. First node executed, second node will be executed, third node will be executed, fourth node executed, fifth node executed, but again from fifth node it will again come back to first node because it is circular linked list. Sixth time when it is again coming to first node, then the condition fails and it will not enter again. So 5 node given, 5 times it will enter into do block. So n node is given, n times it will enter inside. So printf will be executed for n time, so it will be taking n unit time. Temp equal to temp of next will be also executed for n time, so it is n unit time. Okay, coming here for while condition. This while condition, it will be executed for how many times? How many times condition will be checked? That you should remember. First node it will be checked, second node, third node, fourth node it will check, fifth node also it will check. Again coming back to the first node it will be checking, but condition become false, but it will check. So n time for successful comparison it will check, and one time for false condition. When both temp and first become equal also it will check, and then resultant answer will be false. So condition will be checked for n plus 1 unit of time. So adding all this unit time together, T of n is equal to how many n is available here? 3n is available. So 3n plus 1, 3n plus 1. Sorry, it's not 3n, it is 4n, okay? So it is 4n plus 1, okay? 4n 1 plus 1 is a linear equation. It's a linear equation. Okay, so here the time will increase linearly whenever the input is increasing. Input is directly proportional to the unit time consumed. So this can be called as order of n, which is similar to the normal display function that we have already discussed in the initial stage of the course. So let us take this and we will just write that the time complexity of iterative approaches, yes, equation and as well as order of n is the time complexity. Now let us speak about the time complexity of the recursive approach. Then the next one is time complexity of recursive approaches. Okay, recursive approaches, yes, we will discuss about that. Coming to the recursive procedure, let us take the given signature as t of n, time function of n, whereas n is the total number of node available in the circular linked list. Okay, fine. Now coming here to static int flag equal to 0, this will be taking exactly 1 unit of time overall because this will be executed for only one time. Okay, fine. Coming here for this condition, flag equal to 0 is a separate condition, 1 unit. Temp not equal to head is a separate condition, second unit. For making this logical or, then it is 3 units, so it will be taking 3 unit on a total. Flag equal to 1 will be taking 1 unit. Printing temp of data will be taking 1 unit. Now coming the recursive call. When the function signature can be called as T of n, then what are display of CLN? But head comma temp of next, which means first data is printed and now I'm calling it for the second node, passing the address of the second node. So initially there are totally n node available. After completing first node, how many node will be there left? There will be n minus 1 node left. So this recursive call can be taken as T of n minus 1. So what is the recurrence relation? Recurrence relation is T of n is equal to T of n minus 1, T of n minus 1 plus 6. Whereas always I told that if you have a constant, take it 1. So it is T of n equal to T of n minus 1 plus 1. What's the base condition? That's if n equal to 0, what it will happen? N equal to 0, there is no node left. T of 0, no node left. If there is no node left, what will happen? This if condition will evaluate to false and you come out. When you come out, there is nothing to execute, but for checking this condition, it will be taking only 1 unit. So if n is equal to 0, T of 0 equal to 1. If n is greater than 0, then T of n equal to T of n minus 1 plus 1. Okay, so taking this equation, and let us solve the recurrence relation with the help of successive substitution method. Okay, so I'll just take the equation, and this equation will become equation number 1. We are going to perform successive substitution method, whereas in successive substitution method, the value of T of n minus 1 is equal to T. So you have to substitute n minus 1 here in equation 1. So T of n minus 1 is equal to T of n minus 2 plus 1. So this equation we will take it as equation number 2. We will take it as equation number 2. Now take this value, substitute equation 2 in equation 1. So T of n is equal to, what is the value of T of n minus 1? It is T of n minus 2 plus 1 in the equation, and there is another plus 1. So totally it is plus 2. This new equation after substitution will become equation number 3. Now let us find the value of T of n minus 2, which is in equation 1 you substitute n minus 2 instead of n. So the equation will become n minus 2, then again minus 1 minus 3. So n minus 3 plus 1. So this equation we will take it as equation number 4. And now the next task is to substitute equation 4 in equation 3. Substitute equation 4 in equation 3. Okay. Now the total equation will be T of n is equal to T of n minus 2. Instead of that we will take T of n minus 3 plus 2 plus 1. Here in the equation 2 we have another one. So totally it is n minus 3 plus 3. So this equation we will take it as equation number 5. And now we will generalize, because this keeps on going, n minus 1, n minus 2, n minus 3. So we have to just generalize all this thing. So T of n is equal to T of n minus I think it's -1, -2, -3, keeps on changing. Let us take a like general variable for representing that changing value. Plus, this positive term is also changing. +1, +2, +3. If it is -1, here +1, -2, +2, -3, +3. So if it is -k, then here it is +k. So this equation, we will take it as equation number 6. Now, when this process will end, coming to base case, what is the base case? T of 0. When this will become T of 0? When n minus k becomes 0, then it will become T of 0. So when t minus k, n minus k will be equal to 0, minus k on the left side will go to the right side with positive symbol. So n is equal to positive k, n is equal to k. When n is equal to k, then t, it will become T of 0. So T of n is equal to T of, everywhere instead of k substitute n. So it is n minus n instead of k, then it is again plus n. So this equation, it is going to be equation number 7. What is n minus n? N minus n is equal to 0. What is T of 0? 1. So this equation is n plus 1. T of n is equal to 1 plus n. So this equation, we clearly know that it is a linear equation. So the time complexity of recursive approach is also order of n. Okay. So the time complexity of both the techniques, iterative as well as recursive technique, is linear time taking one. Now let us also speak about the space complexity of both the methodologies. So coming to the space complexity, it depends on the memory block that it takes, extra memory block. Coming here to the iterative approach, we have taken two blocks. One is first, the other one is temp. Only two extra block that we have taken, and the two extra block, so 2 unit, that will not change with respect to input change. If n value equal to 1000, 10,000 or 1 lakh, 10 crore, whatever it is, but we will be taking only two pointer variables called as first and temp, extra space. So it is a kind of constant space. So space complexity of iterative approaches, it's constant, order of 1. Similarly, let us also speak about the space complexity of recursive approach. And the space complexity of recursive approach is order of, I'll just tell you, it depends on the space complexity of a recursion depends on the activation record. So here we have a variable called as head and temp, pointer variable called as head and temp. For it, we will be having two blocks, memory blocks, but for every activation record. So how many activation record will be created? 1, 2, 3, 4, 5, 6 activation record for 5 elements. So totally we can clearly say that it is going to be n plus 1 activation record. N plus 1 activation record. Along with it, you also take the static variable, which will be taking only one block. It is not going to be created inside every activation record. So n plus 1 for activation record. Okay. So in every activation record, you are going to take two block actually. So in every activation record, it is going to be two block. So it is equal to 2n plus 2. 2n plus 2. 2 is multiplied with 1 plus 2 is multiplied with 1. So 2n plus 2, and also you can take this one block into account, which makes it 2n plus 3. So the final equation here, space equation is it is 2n plus 3, which is clearly a linear space. So order of n is the space complexity of the recursive approach. As we already know that recursion is a memory costly operation. Okay, fine. So the time and space complexity analysis of displaying both the iterative as well as recursive approach of a circular linked list has been discussed in and out. Okay, thank you students.